Really enjoy this unit.
Oh yeah, do we need a calculator?
You're gonna be fine without a calculator. Okay. So this is an example of a sequence right here. 3, 5, 7, 9. Can anybody give me the next term of that sequence? 11, then. Yeah, good. Here's another one for you. How about this sequence? 5, 25, 6, 25. Somebody tell me the next term. Whatever 625 times 5 is. Oh, I'm sorry. Yes. Bad, Mr. Gens. 125, then 625. So I'm multiplying each term by 5, right? So that's example sequence. How about this one? 0, 1, 1, 2, 3, 5, 8, 13. What would be the next term there?
You tell us. That would be 21.
Why?
Because 8 plus 13.
Yeah, 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. This is the Fibonacci sequence. Yeah, she is smart. She's a cheater. She watched the lesson earlier. Yeah. I did have a student who did that one time. They would come to class and they had watched a lesson previously, so they would recite all the answers in class. I finally caught on what they were doing. They're like, well, I just like to know the answers. I'm like, okay, but you can't then, like, you got to give people time to think about it. So anyway, that was kind of interesting. So this says to produce the first 4 terms and the 100th term of this sequence. This is the terminology used for sequences. A sub n is equal to n minus 5. So if we want to know the first term would be a sub 1 is equal to, and then for n we plug in 1. 1 minus 5, which gives me negative 4 is the first term of that sequence. The second term of the sequence would be 2 minus 5, which would be negative 3. The third term of the sequence would be 3 minus 5, which would be negative 2. And the fourth term of the sequence would be 4 minus 5, which is negative 1. You can make a prediction what the next term is. You see the pattern that's developing right now, right? And if you want to know the 100th term, it is simple to just plug in 100 and subtract 5 and get 95. Hello. Thank you. Okay. In this situation, it's a little bit different. The first term is going to be 3 plus 1, which is 4. The second term is going to be, let's see, 3 times 2 is 6. And 6 plus 4 is 10. The third term will be 9 plus 9, which is 18. And the fourth term will be 12 plus 16, which is 28. Okay. Find the... All right, here we go. So what did you get for the 100th term?
10,000.
Yeah, that's what I got.
A sub n is equal to 3n over n plus 4. Now, look at what happens here. This is kind of interesting. If you do a sub 1, we get what? 3 over 5. If you do a sub 2, you get
6 over 6.
so you get 1, right?
Yes, sir.
And then the third term you
9
get
over 7.
9 over 7. And then the fourth term you get, yeah, so 8 or 12 over 8 is 3 halves. I want you to look at kind of what's being generated here. It gives you a little bit of appreciation for what's happening. In this one, we can see we're going up by 1 each time, right? And if we wanted to then write a rule for it, it wouldn't be that bad. If you look at this situation, this one goes up by 6, this goes up by 8, this goes up by 10. At least you could make a prediction. But notice how the second difference goes up by 2 each time. When the second difference is constant, you know that it's quadratic. We see pattern there. But can you imagine trying to take this data and figure out the next one? Like if you weren't given the rule?
No.
That would be really tough, wouldn't it? In fact, if you were to try to take this problem and go to that That problem would take us hours to do. Be very, very challenging. Let's go with one that's easier. This one, now we see it, the variable in the exponent. We got a sub 1 is equal to, 1 minus 2 is negative 1, and 2 to the negative 1 is? What is 2 to the negative 1? Yes, it's 1/2. We drop it to the denominator. Then we get 2 to the 0, which is 1. Because you plug in 2, so 2 minus 2 is 0. 2 to the 0 is 1. We plug in 3. 2 to the 1 is 2. You can plug in 4. So 2 squared is 4. Can you see what's happening each time? They double. And so a to the 100th is going to be 2 to the 98th power. You just plug it in. You can kind of see what's happening each time. Last one we're going to do before we talk about two specific types of sequences is this letter E. It's interesting to see what happens when you have negative 1 to power. For example, here we get a sub 1 is equal to, we plug in 4 and we get 4. Are we going to add 1 or subtract 1? We're going to minus 1 because negative 1 to the 1 is negative 1. So you get 4 minus 1 is 3. In the second term, it's going to be 8. Is it going to be minus 1 or plus 1? Plus 1, so it'll be 9. And then the third term will be 12. Will it be plus 1 or minus 1? Minus 1 for 11. And then it will be 16 plus 1 or minus 1? Plus 1, which will be 17. So what's interesting here is it goes up by 6, and then it only goes up by 2. And then it goes up by 6, and then again it would go up by 2. This negative 1 creates that kind of bouncing back before or between the numbers that you're adding. All right, so let's talk about the two most common types of sequences that we see. And the first one is what we refer to as an arithmetic sequence. I will give you an example. 1, 3, 5, 7, 9, 11. That is arithmetic. And it's arithmetic because it has what we call a common difference. What is the common difference in that? Common difference is 2. The formula for an arithmetic sequence is as follows. A sub n is equal to a sub 1. Anybody want to guess what a sub 1 is? The first term. And we add that to d, which is your common difference, times n minus 1. That's the formula that's used to generate the a sub nth term. So what we want to do is we want to write a rule. So first we were given rules when we produced the terms. Now we would like to write a rule. Okay? What is the first term here? Later, Gator. What is the next term? Eight. It goes up by 3 each time. What's the next term after that? 11. Then 14. Everybody good with that? So if we want to write a rule, we say that a sub n is equal to the first term, which is 5, plus the difference, which is 3 times n minus 1. So a sub n is equal to 5 plus 3n minus 3. Or a sub n is equal to 3n plus 2. Now that we've written a rule, it's easy for us to find the 20th term, or the 200th term, or the 2000th term. A sub 20 is equal to 3 times 20, which is 60, plus 2, which is 62. Go ahead on a moment, or for a moment, just take some time and write the rule for letter B. Write the rule for letter B. See if you can do that on your own. Go ahead. All right. So did you guys get a sub n is equal to 100 minus 2 times n minus 1? So that would produce 102 minus 2n. Is that what you got?
Yeah.
And then notice that when you produce the 20th term, we plug in 20 and you get 102 minus 40, which is 62. Allie had noticed it. Happens to be the same in first year. Think that's coincidence? We call this the rule of 20. The rule of 20 says that the a sub 20 term for any sequence is always magically 62. I'm totally lying. That's like not a thing. So that's
I just wrote that down.
no, it's absolutely a lie. Completely false.
I literally highlighted them and wrote it down.
I do that every year. One time there's a student who asked, they said, is the 20 term always 62? And I was like, yeah, yes, it is. It's this amazing rule. And they're like, is that like the rule of 72? If anybody's ever done like compound interest and stuff like that, you get this rule of 72 that comes up. And so I kind of ran with that. And I said it first hour, and most people started writing down, but a few people started laughing, and they kind of looked at me like, we know you're joking, Mr. Yannis. So I kind of sold it better this time, huh?
Yeah.
Yeah, all right. Sorry, now it looks like you guys don't trust me anymore.
No.
Okay. All right, what's different about this one?
There's a negative.
Yeah, I don't tell you those same components, the first term and the difference, but can we figure out the first term and the difference?
Yeah.
Yeah, so we have a sub n is equal to the first term plus the difference, which is 4 times n minus 1. So a sub n is equal to negative 3 plus 4n minus 4. Or a sub n is 4n minus 7. So if you want to know the 20th term, you just write down 62. It'd be 73, right?
I got them.
We can even involve fractions. A sub n is equal to 20. What is the difference here? Well, let's come up with a decimal. 39 over 2 would be 19.5. 37 over 2 would be 18.5. What's the difference?
1.5.
Not 1/2, but
Half. Like
negative 1/2.
Negative.
So you have minus 1/2 times n minus 1. So a sub n is equal to 20 minus 1/2 n plus 1/2. A sub n is equal to 20.5 minus 0.5 n. If you want to know the 20th term, what is negative 0.5 times 20? Negative 10, add that to the 20.5, and we get 10.5. The second type of sequence is a geometric sequence. Here's an example of a geometric sequence. 1, 2, 4, 8, 16, 32, 64. What's happening each time?
Double.
You're multiplying by 2. And it creates this type of sequence. A geometric sequence has what we call a common ratio. Common ratio is when you multiply by the same number in each situation. In this situation, you're multiplying each number by 2, each previous term by 2. And so the form is a sub n is equal to, it starts with an a sub 1, just like the previous one. Remember the last formula, what came next was plus, right? Plus the difference. Instead of this one, it's going to be times the ratio, because we're talking about multiplication. And instead of times n minus 1, it's raised to the n minus 1. So we can make this really easy. These are actually easier than the arithmetic ones even. But first, I just want to write out the sequence so far. It says a sub 1 is 2. What would be the next term? Don't say 5. 6, then 18, 54, so on and so forth. Okay, multiply each term by 3. So a sub n is equal to the first term, which is 2, times the ratio, which is 3 raised to the n minus 1 power. That's it. That's how easily you can write a rule for that sequence. The next one starts with 64. What is the next term? 32, then 16, 8, 4, so on and so forth. Okay. So a sub n is equal to 64 times 1/2 raised to the n minus 1 power. This one, the ratio is 3. So we have a sub n is equal to 1 times 3 raised to the n minus 1. What is the ratio here? You can always find the ratio by taking one term and dividing by the previous term. What is 50 over negative 200? Negative 1/4. So therefore, a sub n is equal to your first term, which is negative 200, times negative 1/4 to the n minus 1 power. Only 2 left. What is the ratio here? Ratio is the root of 3. So a sub n is equal to 1 times the root of 3 raised to the n minus 1 power. I'm going to pull just a little trick on you. You could write it just like that, but suppose I want to write it as 3 to the 1/2 raised to the n minus 1 power. What do you do when you have a power to a power? So you could write this as 3 raised to the n minus 1 divided by 2. So those expressions are the same. Last one. Talk to your friend. Find out the ratio. Go. Take 35 seconds. Figure out the ratio. What do you got? Yep, r is equal to negative 2/3. Therefore, we have a sub n is equal to 8 times the ratio, which is negative 2/3 raised to the n minus 1 power. What you think? Not too bad? Take out your homework. Later, Gator. As you look in your homework, there is one assignment that says recursive sequences. I don't want you to do the recursive sequences yet. I would like you to just do the next one, which says sequences. Sequences. Okay. And that's that. I think it's 2 pages. I think it's that and that. I think it extends under here. Yep. Yep.